The universe is a vast and mysterious place, filled with wonders that both captivate and terrify us. We gaze up at the night sky, stars twinkling like celestial fireflies, and ponder the forces that govern our cosmos. And sometimes we imagine scenarios that send shivers down our spines. Today we journey to the heart of our solar system, where a fiery dance of gravity and motion unfolds. We explore a hypothetical event, a cosmic collision of epic proportions. What if Mercury, the smallest planet in our solar system, were to crash into the Sun? This might sound like something out of a science fiction film, but the reality is that the universe is a chaotic and unpredictable place. While Mercury is not going to suddenly veer off course and plunge into the Sun anytime soon, the forces of gravity are constantly at play, shaping and reshaping the cosmos. So let's delve into this thought experiment and uncover the awe-inspiring and perhaps slightly unsettling consequences of such an event. Hold on tight, because our journey begins at the very edge of our understanding. Mercury, the smallest planet in our solar system, is a desolate and unforgiving world. Scorched by the sun's relentless heat, its surface is a barren landscape of craters and dust. Named after the Roman messenger god, Mercury is known for its swift orbit around the sun. Zipping through space at 107,082 miles per hour, it completes one orbit in 88 Earth days. Despite its small size, Mercury is dense, primarily composed of iron and nickel. The Sun, the heart of our solar system, is a colossal ball of burning gas, a giant nuclear furnace that powers life on Earth. Its gravity holds all the planets in our solar system in their orbits, dictating their movements through space. This gravitational pull is not equal for all planets. The closer a planet is to the Sun, the stronger the gravitational force it experiences. This is why Mercury, being the closest planet to the Sun, feels the Sun's gravitational pull more intensely than any other planet. Imagine the Sun's gravity as an invisible web, its threads reaching out to every corner of our solar system. The closer a planet is to the Sun, the more entangled it becomes in this web, its movements dictated by the Sun's immense mass. Mercury, caught in the Sun's powerful grip, is constantly being pulled towards the star. However, its orbital velocity, the speed at which it travels through space, prevents it from succumbing to the Sun's gravitational pull. Instead, it maintains a delicate balance, forever tethered to the Sun but never quite falling in. Now imagine a scenario where Mercury's delicate balance is disrupted. What if some external force, perhaps a rogue asteroid or a gravitational tug from a passing star, were to nudge Mercury off its course, sending it on a collision course with the Sun? At first, the change in Mercury's trajectory might be subtle, a slight deviation from its usual elliptical path. But as the planet draws closer to the Sun, the gravitational pull would intensify, accelerating its descent towards the fiery abyss. Mercury, once a swift messenger darting through space, would become a celestial cannonball, hurtling towards its inevitable demise. The once desolate and barren planet would transform into a fiery spectacle, its surface melting and vaporizing under the Sun's intense heat. The closer Mercury gets to the Sun, the faster it will go, like a ball rolling down a steep hill. Its surface will begin to glow red hot, then orange, then white, as the heat becomes more and more intense. Eventually, the entire planet will be engulfed in flames, a testament to the awesome power of the Sun. The day Mercury met the Sun, the moment of impact would be a cosmic spectacle of unimaginable proportions. As Mercury plunges into the Sun's atmosphere, the friction between the planet's surface and the Sun's gases would generate an explosion of energy, releasing a blinding flash of light and heat. Imagine a colossal wave of fire erupting from the Sun's surface, a fiery tsunami reaching out into space. The energy released from this impact would be equivalent to billions of atomic bombs detonating simultaneously, creating a shock wave that would ripple throughout the solar system. Mercury, once a distinct celestial body, would be vaporized instantly, its material absorbed into the sun's fiery embrace. The sun, though momentarily scarred by the impact, would quickly recover, its immense gravity pulling the remnants of Mercury into its fiery depths. For a brief moment, a new star would seem to appear in the sky, a brilliant point of light that would outshine even the brightest stars. But this spectacle would be fleeting as the light from the impact fades and the sun returns to its normal brilliance. Ripples through the solar system. The after effects of Mercury's collision with the sun wouldn't be limited to the immediate vicinity of the impact. The shockwave generated by the collision would travel outward through the solar system, potentially disrupting the orbits of nearby planets and asteroids. Picture a pond disturbed by a falling pebble, ripples spreading outward from the point of impact. Similarly, the shockwave from Mercury's collision would create gravitational disturbances, causing planets to wobble in their orbits and potentially altering their trajectories. While the impact wouldn't be catastrophic enough to eject planets from the solar system, it could still have significant long-term effects on their orbits. Even a slight shift in Earth's orbit could have dramatic consequences for our planet's climate and habitability. The asteroid belt, a region between Mars and Jupiter populated by millions of rocky bodies, would also feel the effects of the shockwave. Asteroids could be sent scattering in all directions, potentially increasing the risk of collisions with Earth and other planets. A tiny blip for the Sun. The Sun is colossal, over 100 times wider than Earth and over 300,000 times more massive. In comparison, Mercury is but a tiny speck of dust. Mercury's impact wouldn't have a lasting impact on the Sun's structure or lifespan. The Sun would continue to shine, its nuclear furnace churning away for billions of years. While the Sun might not be significantly affected by Mercury's demise, Earth is vulnerable to changes in the solar system's balance. The gravitational disturbances could nudge Earth's orbit, leading to extreme weather and rising sea levels. Increased asteroids and comets after the impact would pose a significant threat to Earth. The solar system is often compared to a delicate clockwork mechanism, with each planet and celestial body playing a crucial role in maintaining its intricate balance. The removal of even a small cog in this cosmic machine, such as Mercury, could have unforeseen and far-reaching consequences. Imagine a group of dancers performing an intricate ballet, their movements perfectly synchronized and harmonious. The removal of even a single dancer would disrupt the flow and balance of the performance, potentially leading to chaos and disarray. Similarly, Mercury's absence from the solar system would disrupt the gravitational interactions between the remaining planets, potentially leading to long-term orbital instabilities. Over millions of years, these instabilities could result in significant changes to the solar system's architecture, potentially even leading to collisions between planets. The delicate balance of our solar system, honed over billions of years, is a testament to the intricate workings of gravity and the laws of physics. Disrupting this balance, even in a seemingly insignificant way, could have profound and unpredictable consequences for the future of our cosmic neighborhood. While the scenario of Mercury crashing into the Sun is hypothetical, it reminds us of the immense forces in our universe. It highlights the delicate balance governing our solar system. Astronomers use advanced tools to study planetary dynamics and predict future trajectories. These studies help us understand the long-term stability of our solar system. The universe is vast and mysterious, full of wonders we are only beginning to comprehend. The scenario of Mercury crashing into the Sun offers a glimpse into the awe-inspiring forces that shape our universe. It reminds us of the delicate balance that governs our solar system. The universe is constantly evolving and changing. Stars are born, live, and die, sometimes in spectacular supernova explosions. Planets form, collide, and reshape their orbits. The universe is full of wonder, beauty, and chaos. As we explore the cosmos, we marvel at its immensity. The pursuit of knowledge is a journey worth taking. The universe is full of endless possibilities. Behind the twinkling stars lies a universe of wonder.